All right, welcome back, you guys. Your favorite trig course. We're going to use these double angle, half angle formulas listed here, as well as our power reducing. So double angle formulas, power reducing formulas, and notice that for the double angles. And let me give you if you remember from last time, you remember how the sine of alpha plus beta was the sine alpha cosine beta plus cosine beta, cosine alpha, cosine beta, right? And so if we have the sine of 2 theta, like let's say we were trying to prove this, then if I let theta be alpha, theta be beta, then I'd have sine of theta, cosine of theta plus cosine theta, sine theta. So I have sine theta, cosine theta plus another sine theta, cosine theta. That's 2 of those sine theta, cosine thetas. So we just proved that first one, the sine of 2 theta. You want to memorize that one. That one you see quite a bit, that double angle formula. Sine of 2 theta is 2 sine theta, cosine theta. So all these have just been proven one way or another. Notice that the cosine has 3 formulas for the cosine for that double angle formula. There's 3 of them, so you can use any of those 3. And then the tangent's got 1, and then we've got these power reducing. So it reduces the power, right? Squared. Now notice it's to a cosine of 1 degree, right? So it's reducing the powers. And then we've got some half angle formulas as well after that. Okay. All right, let me. Oops, why is that doing that? On the half angle formulas, I want to note when we get to working with these, I'll discuss this, but you have to decide whether it's the positive or the minus, depending on where the angle is, on what quadrant it's in. And for the tangent, there's actually 3 formulas. The first one you would have to decide, is it the positive or minus? But here's some alternate ones you can use down here as well. So we'll use those, some examples today. But let's go ahead and start using, let's start out with this first example. And if we're given the cosine of theta is negative 0.8, so here's what our given is, given this stuff. Okay, here's what we know. Notice our angle theta is less than or equal to 180, but greater than or equal to 90. So we're in quadrant 2. So I'm going to draw my theta into quadrant 2. Greater than 90, but less than 180, less than or equal to 180. And then I'm going to use theta prime to fill this out, right? My reference angle, theta prime. So we're given cosine theta is negative 0.8, or negative 0.8 over 1. So here's my adjacent side. Here's my hypotenuse, negative 0.8 over 1. So I go ahead and fill that in. I'm going to go ahead and solve for the remaining side. So a squared plus b squared, this is my b right here, equals c squared. So my b ends up being plus or minus 0.6, right? If I subtract 0.64 from both sides, I get 0.36, and then I square root. And then I got to decide, is b positive or negative? Well, the x is negative, right? The adjacent side should be negative. The b should be positive. So I'm going to put in there positive 0.6, okay? So we solve for that. Now I can compute the sine, cosine, tangent. All right, so number 1 is draw the thing. Number 2, now let's do all these. And then we'll do their reciprocals as well. Cosecant, secant, cotangent, and so on. Well, the sine of theta would be opposite over hypotenuse, so 0.6 over 1. Cosine of theta, we already know that. They gave us, that was negative 0.8. Tangents opposite over adjacent, so 0.6 over negative 0.8. So I punch that in, I get negative 0.75. And now let's find the reciprocal. So the reciprocal sine is a cosecant. So I got 1 over 0.6. Reciprocal of the cosine is a secant. So 1 over negative 0.8. And the cotangent would flip that over. So negative 0.8 over 0.6. Alright, so we've done this first part. We've done all these. Now let's do the double angles. So the sine of 2 theta. So it's part number 3. Sine of 2 theta. So I look up on my formula sheet and I'm like, oh, sine of 2 theta. Or you can look at your reference sheet, right? And it's right here is my double angle formula. All right, sine of 2 theta is 2 sine theta cosine theta. And so we got 2. I know the sine of theta is 0.6. We found that. It was given that the cosine theta is negative 0.8. And then I punch this in. I get negative 0.96. And now we'll do the cosine of 2 theta. And I look up here. I can use any of those 3 formulas I have. I'm going to use the 2 cosine squared theta minus 1. I'm going to use that one right here. But again, I could use any of those, right? I'll use the second one. So we got 2 cosine theta squared. Remember, our cosine theta is negative 0.8, but the cosine theta is being squared. And so 2 times 4 minus 1, I got 0.28, looks like, if I punch that in. And then we also want the tangent of 2 theta. Tangent of 2 theta. So I go up here, I find my tangent of 2 theta. I'm using this one. 2 tangent theta over 1 minus tangent squared. And we know the tangent's negative 0.75. And punch that into my calculator. Okay. So now we've done all the double angles right here. Those 3. Now let's do these half angles. Sine theta over 2, cosine theta over 2, and tangent theta over 2. So now we're using these half angle ones right here. And notice we got to decide if it's positive or minus. So where is this, what quadrant is theta over 2 in, right? So let's do this step number 4. I'm going to start out with asking, where is theta over 2? Well, we know theta was between 100, less than or equal to 180, greater than or equal to 90, right? It was in quadrant 2. So if we just divide everybody by 2, it'll tell us that theta over 2 then is less than or equal to 90 degrees, but greater than or equal to 45 degrees. So if I'm less than 90 but greater than 45, I got to be in quadrant 1, right? So if I'm in quadrant 1, so theta over 2 is in quadrant 1. Well, in quadrant 1, x is positive, so I know my cosine is positive. My y is positive there, and so my tangent's also going to be positive there, right? So that goes for theta over 2. Cosine theta over 2 is positive, and so on. All of them are positive. So let's go ahead now, let's use the formulas. So now I can use the formula I look up there. Sine of theta over 2 is plus or minus 1 minus cosine theta all over 2. We know theta over 2 is in quadrant 1, so it's got to be the positive one. So I don't have to write the plus minus anymore. So 1 minus cosine theta all over 2. Now I know cosine theta, remember how they gave us cosine theta, it was negative 0.8. So I got 1 plus 0.8. 1.8 divided by 2 is 0.9, or 0.95. So the sine of theta over 2 is 0.95. Then I'll do cosine theta over 2. I'll look at my formula sheet. It'll tell me it's plus or minus square root of 1 plus cosine theta all over 2. Again, it's in quadrant 1, so I'm just going to take the positive one. So 1 plus, I know my cosine of theta is 0.8 all over, I'm sorry, cosine theta was negative 0.8 all over 2. So I got 1 minus 0.8, so I got 0.2 over 2, or 0.1 that I'm taking the square root of, which is 0.32. And then tangent of theta over 2, I have three of these I could use. This one I have to just, if I'm going to use that one, I got to decide if it's plus or minus. I know it is the positive one, but I kind of don't like the square root junk. And so what I'm going to use is I'm just going to use this one down here, sine of theta over 1 plus cosine, because I have sine and cosine. So tangent theta over 2 is sine of theta over 1 plus cosine theta. Because our sine of theta was the 0.6, and our cosine was negative 0.8. So I got 1 minus 0.8, so I got 0.6 over 0.2, which is 3. So I don't have to deal with the plus minus or any square roots on that. This next one's similar. This would be a good you try it problem. So if you want to like pause the video, give this a shot, and then compare, that would be a great idea. I'm going to start out here with my givens. I'm given that the cotangent is 1/2 and the sine of theta is less than 0. So I got to figure out like where this is so I can kind of draw this thing. If the cotangent is 1/2, right? And I know the tangent, that's the reciprocal of tangent. So that means the tangent's 1/2, which means the sine over the cosine, tangent sine over cosine, are both positive or both negative. So I'm either, this gives me either quadrant 1 or quadrant 3 where both sine and cosine are negative. Negative over negative would be a positive, right? Now, it gives me more information. It says the sine is negative. Well, if the sine's negative, then I got to either be in 3 is where the y value is negative, or 4 is where I'm at. So the first one tells me it's in 1 or 3. The second one tells me it's in 3 or 4. Their intersection says, oh, it's got to be in 3. Since the sine's negative, I must be in 3. So let's draw this thing into quadrant 3. Okay, there's my theta. I'm going to go straight back. The x-axis. I'm going to call this theta prime. I'm going to use that as my reference angle. And if I know the tangent of theta is 1/2, remember tangent is opposite over adjacent. So using theta prime, the opposite side is 1, adjacent is 2. Now remember, this is quadrant 2, so I got to get my signs correct because I'm using right triangle trig to do this for an angle that's actually more than 90 degrees. So I'm kind of jimmy rigging it. So I got to think to myself, I went in the negative x direction, negative y direction. So make those have the proper signs, because we know in quadrant 3 the sine is negative. We also know the cosine is negative there, right? So those have to be negatives to make this work for us, right? And now we're going to solve for the hypotenuse. So -1 squared plus -2 squared equals the hypotenuse squared. So the 1 plus 4, 5 is c squared. So c is √5. The hypotenuse is always positive, right? Positive length there. All right, so now we have the setup. And so we can go through and we can say, number 1, oops, this was number 1. So number 2, now that we've drawn it, we can find the sine, cosine, tangent, and the reciprocal. Sine is opposite over hypotenuse. So I got -1 over √5. Don't forget to multiply by √5 top and bottom. So you get -√5 over 5. There's our sine of theta. Okay. Oh gosh, you guys, I just realized I made an error on this. I'm so sorry. Right here, if the cotangent's a half, tangent's 2 over 1. I'm so sorry about that. 2 opposite is 2, adjacent 1. That makes a difference. Good grief. My hypotenuse is still √5, but that'll change things because my sine is opposite over hypotenuse. -2 over √5. Sorry about that. Rationalize that. Multiply both by √5. And there we go. Cosine is adjacent over hypotenuse. So -1 over √5. So I have -√5 over 5. And finally, tangent is opposite over adjacent. So 2 over 1. Opposite over adjacent. So we got 2. So there's our tangent. Now we flip those over, right? Cosecant, instead of -2 over √5, it'd be √5 over -2. Cosine, flip that one over, so the secant would be, instead of -1 over √5, it'd be √5 over -1. And cotangent, we already were given that in the first place. So flip that 2 over 1 over to 1 over 2. And now we're going to move into our double angles. So part number 3, let's do the double angles. So the sine of 2 theta is 2 sine theta cosine theta. So use our formula sheet. So we have 2. I know the sine of theta is -2 √5 over 5. I know the cosine of theta from up top here is -√5 over 5. And we keep going here. I got -2 times -2. I got -4. √5 times √5 is just a regular old 5. And then on the bottom, I got 5 times 5, I got 25. So I got, and that's 1/5. So we got -4/5. So sine of 2 theta is -4/5. Oh, that's positive. My goodness, I'm making errors today. That's a positive now. Negative times a negative. Positive 4/5. Now let's find the cosine of 2 theta. And so I look on my formula sheet, and I'm going to use, you can use any of those 3, but I'm going to use 2 cosine squared minus 1. So I got 2. The cosine of theta is -√5 over 5. But remember, the cosine is being squared. So -√5 times -√5 is a positive 5. 5 squared is 25. So I got 2 times 1/5 minus 1. I got 2/5 minus 5/5 is -3/5, right? 2/5 minus 1, -3/5. So there's our cosine of 2 theta. And let's do the last double angle. That'd be the tangent of 2 theta. Again, look on my formula sheet. And you got 2 tangent of theta over 1 minus tangent squared. I know the tangent of theta is 2. So we got 2 times 2 over 1 minus 2 squared. So I got 4 over 1 minus 4. So I've got negative 4/3 for the tangent of 2 theta. Okay. And then the last part on this is the half angle. Half angle. So step number 4. Where is theta over 2, first of all? Well, we know theta is in quadrant 3. So I'm less than or equal to 270, but I'm greater than or equal to 180. And so where is theta over 2? What's the theta right there? I'm less than or equal to 135, but I'm greater than or equal to 90. So I'm bigger than 90, but less than 135. I'm somewhere in quadrant 2. Okay, so if I'm in quadrant 2, my x is negative, my y is positive. So my cosine, I'll write it, cosine theta over 2. My cosine's negative, my y is positive. And remember, tangent is sine over cosine. So if the y is positive, the x is negative, then this will be negative. So let's start and let's write these now. So we got sine theta over 2 is plus or minus square root of 1 minus cosine theta all over 2. We know the cosine's negative in quadrant 2, right? The x value is negative there. Oh, I'm sorry, this is sine. Just kidding. Sine is positive. So we're going to do the positive one. So sine theta over 2 positive root 1 minus, and then we plug in the cosine of theta. What was our cosine of theta up here? Cosine theta is negative root 5 over 5 all over 2. And then we'll clean this up. So I got 5 over 5 plus root 5 over 5. So 5 plus root 5 all over 5 all over 2. That over 1 multiplied by the reciprocal. So I got 5 plus root 5 times 1 all over 10. And there's our sine of theta over 2. Okay, let's do cosine theta over 2 plus or minus square root of 1 plus cosine theta all over 2. We know that cosine theta over 2 is in quadrant 2, so it's negative. So we're going to pick the negative one. Cosine theta over 2 will be a negative 1 plus, and our cosine is negative root 5 over 5. And so we got 5 minus root 5 all over. Five minus root 5 all over 5 all over 2. So we got negative square root of 5 minus root 5 all over root 10. There's our cosine theta over 2. Last one will be tangent theta over 2. And I'm going to use, I'm not going to use the plus minus one. I'm going to use the one with the sine and cosine. So it establishes my sine for me. So tangent theta over 2 is sine over 1 plus cosine. Well, our sine here is negative 2 root 5 over 5. Our cosine was negative root 5 over 5. So this becomes negative 2 root 5 over 5. This is 2 minus root 5 all over, well, that's over, I'm sorry, that's a 2 right there. And so we got negative let's see, that'd be, oh gosh, I'm really messing this up again. So this is 5 over 5 minus root 5 over 5. So that's 5 minus root 5 all over 5. There we go. Now I'm going to multiply by the reciprocal. So yeah, those 5's cancel right there. And so we've got negative 2 root 5 over 5 minus root 5. Now, to be proper about this, I really should rationalize my denominator. So the only way to do that is multiply by the conjugate, right? 5 plus root 5. Top and bottom will rationalize this. So I'm going to distribute that, and then I'm going to FOIL this down here. And so we got negative 10 root 5 minus 2 times 5, which is minus 10, all over 25 plus 5 root 5 minus 5 root 5 minus 5. See how those cancel? So you got 25 minus 5 on the bottom. So you got negative 10 root 5 minus 10. This is all over 20. Or negative 10 root 5 over 20 minus 10 over 20, which is negative root 5 over 2 minus 1 over 2, or negative root 5 minus 1 all over 2. And that's tangent theta over 2. All right, so let's now use the half angle formulas in a way to find the exact value of the sine of 22.5 degrees. And so obviously we don't have 22.5 degrees on our formula sheet. But we do have 45 degrees, and I know 45 over 2 is 22.5, right? 45 divided by 2 is 22.5. So then I look at my formula sheet and I'm like, oh, the sine of theta over 2 is plus or minus the square root of 1 minus cosine theta all over 2. Well, 22.5 degrees is in quadrant 1, so I know it's the positive one, right? So here's my theta. That is that 45 degrees. And so I know it's a positive 1 minus cosine theta. In this case, theta is the 45. And now I can do this. I can find the sine of 22.5 degrees because it's half of 45. And so I got positive 1 minus, and then I look up on my unit circle, right? 45 degrees has a cosine that's root 2 over 2. And so I've got 2 over 2 minus root 2 over 2 is 2 minus root 2 all over 2 all over 2. So we got 2 minus root 2 all over 4. Square root of the top, square root of the 4 is just a 2. So there's the sine of 22.5 degrees. Is exactly this. 2 minus square root of 2 all over 2. So we have the exact form of it. Similarly for the tangent of 22.5, I'm going to clear out some room here. Tangent 22.5. That's the same as the tangent of 45 over 2. And so then I'll use the fact that the tangent of theta over 2 is the sine of theta over 1 plus cosine of theta, right? And so the tangent of the 22.5 degrees ends up being the sine of 45. Well, the sine of 45 is root 2 over 2. The cosine of 45 is root 2 over 2. And so we got root 2 over 2 over 2 plus root 2 all over 2. So we got root 2 over 2 plus root 2. And we really should rationalize that. So 2 minus root 2. And so we end up with 2 root 2 minus 2 all over, that would be 4. Minus 2 would be over 2. And so we got root 2 minus 1, right? Because that's 2 root 2 over 2 minus 2 over 2. So root 2 minus 1 right there. And that's the tangent of 22.5 degrees. All right, let's rewrite this one now. We got 1 minus 2 sine squared pi over 12 using a double angle formula. So one of the double angle formulas says that cosine of 2 theta is 1 minus 2 sine squared of theta. So you see how we have 1 minus 2 sine squared of pi over 12. So my theta is pi over 12. So this will be cosine 2 times, what's my theta? Pi over 12. So this just ends up being cosine of pi over 6, 2 pi 12ths, pi over 6. And then we know the cosine of pi 6, right? You look on your unit circle, and you know the cosine there is root 3 over 2. So 1 minus 2 sine squared of pi 12ths just ends up being root 3 over 2. All right, now let's establish some identities now. So what I'm going to do is I'm going to work with this left-hand side on this one, and I'm going to show that it's equal to the right-hand side. I'm going to show that it's equal to that cosine 2 theta. The first thing I'm going to do is I'm going to put in terms of sines and cosines. So cotangent's cosine over sine minus the tangent, sine over cosine. Same thing on the bottom here, that cotangent, I got a plus a tangent. Now I'm going to get a common denominator. So I need to give this one a cosine, so it matches the cosine on the other right-hand side, and I need to give this a sine. So then that becomes cosine squared minus sine squared, and that's all over that common denominator of cosine sine. Or, yeah, I'll write it cosine sine. All over. Now let's do the denominator, those two, and let's get them as one fraction. So this one needs a cosine. This one needs a sine. So we got cosine squared theta plus sine times sine, sine squared theta, and this is all over that common denominator, cosine sine. Now don't forget, sine squared plus cosine squared, that's 1. So you got 1 over cosine sine. Top is still cosine squared minus sine squared all over cosine sine. But we have one fraction over one fraction, so we can keep change flip on this. Multiply by the reciprocal, if you will, cosine sine over 1. Now, I got to do it to the top. If I do it there, I got to do it over here, top, and see how those cancel right there. And so I'm just left with cosine minus sine squared over 1. Cosine squared minus sine squared all over 1, right? Well, if I look on my double angle formulas, I have cosine squared minus sine squared. So you have cosine squared minus sine squared is equal to cosine 2 theta. So that's cosine 2 theta. And there we have it. I just proved that identity is true. Let's keep going.
Do you think you can go?
All right, let's keep going with these here. Again, another establish the identity. Here, what you want to see is this one is the double angle identity. So on your sheet you have cosine 2 theta. You know, there's 3 of these cosine 2 thetas, but one of them is 1 minus 2 sine squared theta. So I'm going to immediately replace that with cosine 2 theta. And then the rest of this on the left is the same. 4 sine theta, cosine theta, at least for now. Okay. And I'm looking at that 4 sine theta, cosine theta, and the other double angle formula, and this one you really should definitely memorize this. 2 sine theta cosine theta is equal to sine 2 theta. This is 4 sine theta, but if you think about that, isn't that 2 times 2 sine theta cosine theta? And so then this gets replaced with sine of 2 theta. 2 sine theta cosine theta is sine of 2 theta. And now notice here, now we have 2 sine 2 theta and a cosine 2 theta. And I'm using this again. Right, this is like 2 sine theta, but my theta is 2 theta, cosine theta, right? But my theta is actually 2 theta. So 2 sine theta cosine theta is just the sine of 2 theta. But in this case, the theta should be replaced with 2 theta. So that ends up being sine of 4 theta. And there it is. We just established that identity. All right, let's power reduce this cosine of 4 theta. And so what I want to use is this cosine squared of theta is 1 plus cosine 2 theta all over 2. I'm going to use that because what I have is I have the cosine of 4, which is a cosine squared times another cosine squared. And so I can power reduce both of those and replace them with 1 plus cosine 2 theta over 2 and replace the other one with the same thing, 1 plus cosine 2 theta all over 2. Because I'm trying to get it into a first degree instead of a fourth degree, right? I started with a fourth degree, cosine theta to the 4th power. And now what I'm going to do is I'm going to multiply I'm going to FOIL this, first outer inner last. So I got 1 times 1 is 1, plus a cosine 2 theta plus another cosine 2 theta. So that's 2 of these cosine of 2 thetas. And then my last one, cosine times cosine, is a cosine squared 2 theta. And this is all over 4, right? And so what we have is we have a 4th plus 2/4, or 1/2, cosine 2 theta, plus 1/4 cosine squared 2 theta, right? In other words, each of those are over 4. And so everything's to a first power of a cosine, or I should say this one's to a first power of a cosine, cosine 2 theta. But the problem is this one right here, cosine squared, right? It's cosine 2 theta quantity squared. So I'm going to have to power reduce that one as well. So cosine squared of 2 theta would be, according to the formula, 1 plus cosine of 2 times, but if you notice, my theta is 2 theta here. Right, that theta is being replaced with 2 theta there. So it's 1 plus cosine 4 theta all over 2. So let's see what we got here. 1/2 cosine 2 theta plus a 4th times, and then I'm going to put this in. 1 plus cosine 4 theta all over 2. And that's 1/2 plus 1/2 cosine 4 theta, right? Each of those is over that. And so we'll take a 4th root at each of those. So we got a fourth plus a half cosine 2 theta plus an eighth cosine 4 theta, and a fourth, or 1/4 plus 1/8, 2/4 plus 1/8 is a 3/8. And there we have it. Appreciate you guys watching. Hopefully that gives you a little bit to work with. We'll see you guys next time.